class. Yesterday we have seen how to obtain the transfer function using signal flow graph, right? So the basic fundamental equation is using one formula we can obtain the transfer function, right? That is Mason's rule. By Mason's rule, the transfer function of a system is given by sigma k, k, del, where k is the number of the forward path, tk is the path gain, del can be found out by 1 minus sum of the loop gain plus sum of the gain product of two non-touching loops minus sum of gain product of three non-touching loops, and so on. And the delta k is the value of delta calculated by removing all the loops from the kth forward path that we will discuss today. So we have seen how to calculate the loop gain, everything, right? So yesterday we started one problem. Yeah, these are the problem. Yeah. So we will continue. So in order to find the transfer function, the first procedure is to find the number of forward path. That is very important. K, if you make any mistake in finding the number of k, number of loop, you will get wrong answer, right? So be careful while selecting all those things. And the next step is to find out the, we have to identify the number of loops present in the signal flow graph. That means we have to, you have to start from a node and travel from that node to, again you have to come back to same node. That kind of node is called feedback, loops. Forward means we have to traverse from input node to output node. That part is called forward part. In order to find the gain, just multiply the branch gains, right? So yesterday's problem, we have found out that two forward paths. One is from x1 to x5 via a12, a23, a35 and a45. The corresponding forward path gain is a12 multiplied by, that is t1, right? And one more feedback path was there, it is also from x1 to x5 via x2 and x3. Corresponding gain also we have calculated. Next we have seen how many loops in the given problem, and we have identified that there are 5 number of loops, right? So next step is what? We have to find the loop gain. So for the first loop, let it be L1, which is equal to gain product of the corresponding path gains, that is A23 multiplied by A32. And for the second loop, L2, the product of path gains, that is nothing but A23 multiplied by A34 multiplied by A42. And L3, it is a self node because there is only one node and it is started from one node and ending at the same node. That is called self node. So there is only one path gain, that is A14, right? Again, L4 can be written as A23 multiplied by A34 multiplied by A45, again A52, and L5 can be obtained as A23, A35 and A5. So we have identified the loops, and next step is what is next step?
Identifying two non-touching loops, sir.
Yeah, correct. You have to identify the number of two non-touching loops, three non-touching loops, four, and so on, right? So first of all, we will see how many two non-touching loops. Non-touching loop means these two loops should not touch each other. That means there should not be any common node. So if we take, we have 5 loops, right? L1 and L2. There is a common node, right? So it is a touching loop only, so we cannot type that loop. What about uh, first loop and third loop?
Yes, sir.
Is it touching?
No, sir.
It's not touching, right? Yeah, loop, right? Loop 1 and loop 3. They are not touching because there is no common node. So if we draw the corresponding diagram, it's A23, A32. It is these two loops are not at all touching. Okay. Is there any other loop, non-touching loops?
L3 and L5, sir.
What about L1 and L4? L1 and L4 is touching. L1 and L5 also touching, right? So another loop is L5 and
L5 and L3, sir.
L5 and L3, correct. So if we draw the diagram, it looks like this. A43, A35, is A52, and here it is at self. Is there any other non-touching loops? Sorry?
No, sir.
Yeah, correct, right. Only two non-touching loops exist in this. Next step is we have to find the gain, product gain. So for the first non-touching loop, let it be P1, which is equal to product of all the branch gains of the two non-touching loops. That is nothing but A23 multiplied by A32 multiplied by A44. And similarly, for the second non-touching loops, it is P2, it's A43 multiplied by A35, again A52, A4. Right. So next step is to find the number of 3 non-touching loops. Is there any 3 non-touching loops exist in this given problem?
No, sir.
No. Yeah. There is no. There are no combinations of 3 or 4 non-touching loops. Right. Okay. So the next step is to evaluate the delta. So how can we calculate the delta? Delta is nothing but 1 minus sum of the loop gains. That is L1 plus L2. Our loop gains are L1 plus L2 plus sum of the gain product of two non-touching loops. Right? That means P1 plus P2. Remaining are 0, so we don't need to worry about it. So if we substitute here, we get 1 minus. What is L1? Oh, not L1 plus L2. We are having 5 loops. So L3, L4 plus L5. Right. So if we add that, we get A23, A33 plus A23, A34, A42 plus A44 plus A23, A34, A43, A52 plus A22, A35, A52. Right. Plus P1 and P2, right? P1 is nothing but A23, A32, A44 plus A22, A35, A52, A44. Right? So this is our delta. So next step is we got T1 and T1, T2 and delta. The remaining things we have to find out delta 1. Right. So how will you find delta 1? So in order to find delta 1, what is the what Mason is telling? We have to calculate the delta for the loops which is not touching the forward path, each forward path, right? So if you take the first forward path from S1 to S2, so this is our first forward path. This is our first forward path. This is our first forward path. Is there any loop which is not touching this forward? Any loop exists? Not right. All the loops are touching the forward path, this forward path. Right. So if you want to calculate delta for that, how will you calculate? 1 minus sum of the loop gains. There is no loop, right? So 0. Since there is no loop, there won't be any 2 non-touching loop, 3 non-touching loop, nothing. So the answer will be 1. Right? So if you find out delta T2, then you will understand the concept correctly. What we have to do is we have to calculate the delta for the loop which is not touching the second forward path, kth forward path. So since we are dealing with the second forward path, is there any portion means loop not touching this loop? This is the right, yeah, this loop, this self node is not at all touching the forward path with gain f, right? This is not touching. So is there any issue with presentation or anything? You can go right. Your voice is not clear. Someone is telling something, but it is not clear for me. Can you put in the chat box? It's fine. Okay. Okay. Thank you. So we have to find out delta 2 for this. That is the meaning. This is the loop which is not touching the second forward path. So we have to find delta for this loop. So how will you calculate? It is 1 minus sum of the loop gains. Here the loop gain is, we are having only one loop, that is L1 equal to A44. So we can write 1 minus A44 plus sum of the gain product of the two non-touching loops. Here only one loop exists, so we don't need to worry about the other thing. So the answer will be 1 minus A44. So we can find out the final transfer function C of s by R of s is equal to T1 delta 1 plus T2 delta 2 divided by delta. What is T1? It is A12, A23, A34, A45 multiplied by delta 1. Delta 1 is 1 only plus T2, which is A12, A23, A35 multiplied by delta T2. Delta T2 is 1 minus A44. The whole divided by delta. Anyway, I am not going to write this a very lengthy one. So this will be the final transfer function of the system using Mason's limits. Clear? If you have any doubt, please ask. Hope everyone understood the concept. So we will move to the next problem. So you can note down this question. This R of S branch gain is 1. And the next branch gain is 1 by S. One more is there. This also 1 by S. 3. There is a feedback loop like this. It's minus 10. One more loop is there. This minus 24. And one forward path is like this. Is gain 1. And this is output series. So the question is how to find the transfer function U of by R of S from this signal flow. So again, the first step is to identify the number of forward paths. So how many forward paths exist in this graph? Two, right? So we have to, so in order to find the forward path, we have to start from the input node. So I'm going like this. R of S 1, again 1 by S. Anyway, we cannot come back. That is not a forward path. We will further, we will move forward 1 by S. Again, we can reach the output. So this is one of the forward paths. And again, one more forward path is there, like this. Again, we will start at the input node R of S, gain 1, and 1 by S. Likewise also, I can reach the output, gain 1. So, K equal to 2. So the next step is to find out the loop gain, the forward path gain, T1. T1 is 1 by S, 1 multiplied by 1 by S multiplied by 3. Is equal to 3 by x square, and T2 is equal to 1 by S. So the next step is identify the number of loops. Right. How many loops exist here? Two loops exist, right? I will draw the waveform. This under this minus 2. Because it is starting from this node and it is coming back to the same loop. So this is one of the loops, and one more loop we have one for this, one for this. The feedback gain is minus 10. So this is the second. So next step is to find out the loop gains. Let it be the first one is L1. So if you take it is minus 10 by S. L2 becomes minus 24 divided by S square. And the next third, we have to see how many possible combination of two non-touching loop, three non-touching loop, and so on. Is there any non-touching loops exist in this? No, right? Because we are having only two loops. That two loops are having common nodes. They are touching each other. So we can write there are no combination of non-touching loops. Right? So we got all the things. Next, directly you can evaluate the transfer function. This C of S. Sorry, in order to find this, we have to find the delta first. Is 1 minus sum of the individual loop gains, product of the loop gains. It is L1 plus L2. Since there is no combination of two non-touching loops, we can mark it as 0. So delta becomes 1 minus 10 by S minus 24 by S square. So this can be written as 1 plus 10 by S plus 24 by S square. Right. So the next step is you have to find delta 1. Delta 1 is the value of the delta obtained for the by removing the loops which is not touching the forward path, right? So in this waveform we are having only two loops. One loop is this. This is touching this forward path, and another loop is like this. This also touching the other forward path. That means there is no other waveforms exist. So we can write just 1 minus 0 equal to 1. Similarly, delta 2 also we can write 1 minus 0 equal to 1. So finally, we can write C of S, R of S equal to T1 by 1 plus T2 delta by delta, and the T1 is 3 by S square plus T2 is 1 by S, right? Divided by 1 plus 10 by S plus 24 by S square. So if we solve this, we will get 3 S plus 3 divided by x square plus 10s plus 24. So this will be the answer, will be in S level. Here, one more problem. So what are this question? This is the input node R of S. can write as G1 itself. So to gain G1 in S domain. G2, G3, G4, G5. Look at this point, H1, and then it is here, H2, one more is eventually here one more branch is there. This is G8, this is G7, this is G6, this is H4. So this is the signal for the, we have to find UFS by RS. So how we find? So first step is to identify the forward path. So if you start from this input node, this is one of the forward path. Is there any other forward path exist?
No, sir.
Yeah. Because only one forward path exists in this, right? Because if you go like this, you cannot go like this. Here, this is a feedback. So after reaching this point, you cannot go like this. Again, at this point, if you come back, means it is not a forward path. Again, the last branch also. So there is only one forward path. It can be done like this. G1, G2, G3, G4, G5, and corresponding loop gain will be G1, G2, G3, G4 and G5. So the next step is find out the loops. How many loops exist?
4 loops, sir.
With G1 and H1 there is a loop like this. G1, H1. This is the first loop. Second loop between G4 and H2. second loop. Third one, something like this. G2, G3, G4, G5. And it is coming back to the same loop with a gain of no, G here also. Right. This is G8, G7, and G6. Any other loop exists? Is there, right? See, if you start from this node, if we travel like this, we can come back. So that is also a loop. So there is a fourth loop. It can be drawn like this. G7. This is H4. So we have four. We have identified the four loops. The next step is to write the gains. Let it be. This is L1 is the loop gain for the first one. That is G1 H1. L2 will be the second. This is G4 H2, and L3 will be G2 G3 G4 G5 G6 G7 G8. Right. And the last one is G7 multiplied by H4.
Sir,
Sorry?
sir, L1
Voice is not
product
clear.
of
Can you put in the chat box? Your voice is not clear. Can you put it in the chat box? L1 is J2 multiplied by H1. 1 second, I'll check. H2, yeah. Actually, this is G2, right? Correct. G2 multiplied by H1. So the next step is we have to find the delta, right? So in order to find the delta, the third step is identify the non-touching loops. So how many non-touching loops exist here? If you take loop 1 and loop 2, they are not touching, right? So the first possible combination is loop 1 and loop 2. They are not at all touching because there is no common node. And the second combination is if you take loop 1 and the loop 3, it is touching. There is a common node, so we cannot uh, select that one. And if you compare with L4, yeah, L1 loop 1 and loop 4 is also non-touching loop. Right? If you take loop 2, loop 4, right? So there are three combinations, loop 2 and loop 4. These also non-touching. So let me complete the signal, right? For the first one, it look like this. This is G2 H1 and loop 2 is G4 H2. So these are non-touching. And in the second case, loop 1 and loop 4, right? Loop 1 can be like this. Loop 4 is somewhere here, right? So there is G7 H4, right? So this is also non-touching. And the third combination, this is the first one, this is the second one. So if you draw the third one, it's like J4, G4, H2, and this loop is somewhat here. G7, H4. And this also not touching. So next we can directly evaluate P1. For P1 is the first possible combination, that is the gain product of these two non-touching loops. So we can write H1, G2, G4, H2. For this combination, P2 equal to H1, G2, G7, H4. And the third one, G4, H2, G7, H4. So is there any three non-touching loop exist in this?
Yes.
Is there, if you see L1, L2 and L4, right? L1 is this one, L2 is this one, L2, L3, L4 is this one, right? These three are non-touching. There is no common nodes. So in this, compared to the previous one, here there is a three non-touching loop. That is non-touching loop exist in this problem. It can be drawn like this. G2 H1, G4 H2, and is G7 H4. This will be the, this can be written as P3, the gain product of all the loops. So P3 can be written as G2 H1, G4 H2, G7 H4. Okay, there is no possible combination of 4. No combination of 4. Non-touching. So we don't need to see hereafter. So how can we write delta? Delta can be written as one minus sum of the loop gains. We have 4, right? So it is L1 plus L2 plus L3 plus L4 plus sum of the gain product of two non-touching loops. That is, okay, sorry, here one variable we can change it. That's P1, P2, P3. It can be written as P4. We can write P1 plus P2 plus P3 minus sum of the gain product of three non-touching loops. So we have one three non-touching loop with the product gain P4. So if you substitute all the values, you get 1 minus H1 G2 plus G4 H2 plus G2 G3 G4 G5 G6 G7 G8 plus one more is there G7 multiplied by H4. This is the sum of the loop gain. Again, two non-touching loop gain you have to write. I will write this plus G2 H1 H2 G4 plus H1 G2 G7 H4 plus G4 H2 G7 H4. Right. What about P4? We did not calculate P4, right? Calculate it. P4. Yeah, correct. Minus H1 G2 G4 H2 G7 H4. So this is the value of delta. Next step is to find out delta 1 and delta 2. Sorry, there will be only one. There is only one forward path case, so we have to find out delta 1. So in order to find delta 1, what you have to do? You have to find is there any loop which does not touch the kth forward path, right? So kth or you have only one forward path. So how this forward path is like this? G1, G2, G4, G5. Is there any portion? Is there any loop which is not touching the forward path? Is there, right? Or last loop number 4. G7 H4. So this portion is not touching the first forward path. Right. This is not at all. So we have to find delta for this portion. Find delta for this part of the simulation. So that delta will be equal to delta 1. So in order to find the delta 1, first of all, you have to see the equation will be like this. How many loops exist in this? Only one loop, right? And that can be written as E7H4. Since only one loop exists, there is no concept of touching loops. So we can write delta 1 equal to 1 minus sum of the loop gain. We have only one loop. Substitute here. G7H4. So finally, we can write that G of S by R of S is equal to G1. G1 is G1, G2, G3, G4, G5 multiplied by delta 1 is G7H4. The whole divided by delta. And substitute the delta here, we will get the value. Clear? If you have any doubt, please ask, because next class we will move to the next unit. The first unit is completed here. If you have any doubt, please ask. Okay, it is a software, and we will see some analysis part. Okay. So first we will complete the analytical and theoretical.